Okay, so I've got my graphical estimations up top, found the equation for it in part B, did my numerical by plugging it into Desmos and just getting these like 3 decimal answers. That's my numerical solution set. Then again, part D, the bread and butter of this whole unit is the, how do I find it algebraically? So I set the equation, y equals 1.5 equal to my equation that I found for the sinusoid, and I need to figure out, right, I need to solve for x. First thing I'll do is subtract 1, so I get 1/2, and then I divide by 3, and so I get 0.5 thirds is equal to the cosine of 2 pi over 16 times x plus 7, right? 1/2 minus 1 is a half, or sorry, 1.5 minus 1 is 1/2, divided by 3 is 0.5 thirds. That is really ugly. 0.5 is 1/2, and 1/3 of 1/2 is going to be 1/6. So let's just change that to there. So we can work with that the whole way through then. Again, I got a ratio equals the cosine of this argument. So the argument has to equal the arccosine, all of the sets of angles that have a cosine ratio of 1/6, the arccosine of 1/6. Undo over here, I'd multiply by 16 over 2 pi and subtract 7, so x equals -7 plus 16 over 2 pi times the arccosine of 1/6. And then I actually have to plug in the equation. What is the arccosine of 1/6? Well, it's the positive or negative value that my calculator gives me, the inverse cosine of 1/6, and every angle coterminal to it. And I have to distribute that 16 over 2 pi to both things. 2 pi times the inverse cosine of 1/6 plus 16 over 2 pi times 2 pi n is just 16n, because again, 16 is my period. So I need to find out, using my calculator, what is 16 divided by 2 pi times the inverse cosine of 1/6. Make sure I'm in radian mode, and make sure I put 2 pi in the denominator, in parentheses. Get -7 plus or minus 3.57, come on, pen, 574 plus 16n. And then I actually want to split it. X is -7 minus 3.574, and every period away from that, or x is -7 plus 3.574, and every period away from that. So x is either -10.574 or x is -3.426 plus 16n. And to find the particular solutions, I'd want to make a little table of like n is 0, n is 1. Right, the zeros are the easy ones. I got x is -10.574, or x is -3.426. And then n is -1. I just have to subtract 16 from each of these. I get x is -26.574, or x is -19.426. I'm looking at the problem. Both of those are actually off of the solution, so I didn't need to do that one, but those are solutions too. It starts at -10 because we had a phase displacement that was back at -7. If I added 16 to this now, though, I would get x is negative 10.574 plus 16 would be 5.426. Negative 3.426 plus 16 would be 12.574. I do want to find that one last one. I need to go to n2, add 16 to this, and I get 21.426. The last one I estimated was at about 21.5, so that's it. Add 16 to this one if I wanted to. 28.574. The 5 solutions that you see are just right there. I wanted to find the first one over 100 in part E. I do 100 divided by the period. So 100 divided by 16 in this case is 6 1/4, so it's about 6 cycles away. Not quite 6 full cycles away. Both of my solutions are starting in the negatives, so I'm guessing we're going to need to go to the 7th full rotation. So if I try the first one, x is negative 10.574 plus 16 times 7, 7 full periods after this. 16 times 7 is 112. X is 10.574 plus 112. And this would give me x is 101.426, which I'm sure that's going to be my one. I can check the other one. It's going to be larger than that one. Plus 7 full periods away. 3.426 plus 112. I get 108.574. So this is my first one past 100. I could look at each of these. I could be confident that this is my correct answer, because if I went 16 before either of these, I'd be way before 100. So this is definitely the one answer past 100 that has that solution.